For each equation, choose the statement that describes its solution. If applicable, give the solution. So let's look at the first one. We have 4 times the quantity v plus 1 minus 7 equaling 3 times the quantity v minus 1 plus v. So as we did before, we work one side at a time. So start by distributing the 4 times the v plus 1. So that gives us 4v plus 4 minus 7. Now let's combine like terms. So we have 4v, and when we combine positive 4 and negative 7, that gives us negative 3. Now we can work the right hand side. So again, start by using the distributive property. So this gives us 3v minus 3 plus v. Combine like terms. So 3v plus v is 4v. Now at this point, we know that our answer is all real numbers since the left-hand side equals the right-hand side. But another way you can tell as well is when we go to isolate and I'm moving the 4v from the right-hand side to the left-hand side by taking its opposite. The variable is eliminated on both sides. So when your variable is eliminated, whether you're solving an equation or inequality, look at the remaining statement. If the left-hand side equals the right-hand side, and as I said, your variable was eliminated, then your answer would be all real numbers. So let's look at the next one. Here we have 3 times the quantity u minus 2 minus 5u equals negative 2 times the quantity u plus 2. So again, one side at a time. So we're going to start by distributing. This would give us 3u minus 6 minus 5u. Combining like terms, 3u minus 5u is negative 2u. So on the left-hand side, we have negative 2u minus 6. Now let's work the right-hand side. And again, we'll start by using the distributive property. That would give us negative 2u minus 4. Now we're going to isolate our variable. So if I'm eliminating the negative 2u on the right-hand side, or moving it to the left, I take its opposite. So again, my variable is eliminated from both sides. Now look at the difference. In our first example, the left-hand side equaled the right-hand side, so we have an infinite number of solutions. When our variables are eliminated completely and the statement is false, negative 6 does not equal negative 4, then we have no solution. When would we have a solution like u equals? In problems like we did previously, where we solved and we got, in this case, like v equals negative 1. So if the variable is not eliminated and you can finish the problem, that's where you'll put in a value for whatever the variable is. Our next example. So in these, there's more than one way to work the problem. For me, what I do and I suggest is clearing the fractions by multiplying by the least common multiple or the common denominator. So when we look at our denominators 5, 3, and 1, our common denominator is 15. So I'm just going to rewrite the problem. And I'm going to multiply each numerator by my common denominator, in this case 15. So instead of multiplying first and then reducing, I prefer and I recommend reducing first. So 5 goes into 15 3 times. So this would leave me with 3 times y, which is 3y. Next, I reduce the 3 and the 15, so 3 goes in 15 5 times. So that leaves me 5 times y, which is 5y. And on the last one, 1 goes into 15 15 times, and positive 15 times 4 is positive 60. So much easier to deal with it now. So nothing left to do except for isolating my variable. So I'm going to subtract 5y from both sides so I can isolate my variable on the left hand side. 3y minus 5y is negative 2y. In my last step, I'm going to divide by my coefficient, negative 2. So 60 divided by negative 2 is negative 30. My next problem. I have negative 1/2 x minus 2/3 equaling negative 6/7. So I want to find a common multiple so that I can reduce my fractions. So the common multiple of 2, 3, and 7 is 42. You can always just multiply these numbers together and use that number as your common multiple to reduce or eliminate your fractions. So I'm going to rewrite and multiply each term by 42. That was my common multiple. So just as we did before, we're going to reduce first. So 2 goes into 42 21 times. Now I multiply what's left. So 21 times negative 1x is negative 21x. Next, I'm reducing 3 into 42, and that goes 14 times. So don't forget this sign here. So I'm multiplying 14 times negative 2, which is negative 28. And for the last, 7 goes into 42 6 times. So I'm multiplying 6 times negative 6, which is negative 36. So now we're to the stage where we're going to isolate our variable. So I'm going to add 28 to both sides because I'm isolating my variable on the left hand side. And negative 36 plus 28 is negative 8. I'm going to divide by my coefficient, negative 21. Remember, a negative over a negative is a positive, so that gives me 8/21. And I would reduce if I could, but there's no common factor of 8 and 21. So my answer is going to be x equals 8/21. My next problem, solve for w. Negative 4w minus 5/2 equals 5/3 w plus 2/3. So again, I'm going to start by rewriting this. So negative 4w is the same thing as negative 4w over 1 minus 5 halves equaling 5/3 w plus 2/3. So we're going to multiply each by the common multiple or a common multiple, which would be 6. If you use something different, if you used 18, that would work. But since 6 is the least common multiple, it will keep my numbers smaller. But any multiple or common multiple of 1, 2, 3, and 3 would work. So next I reduce. So 1 goes into 6 6 times, and 6 times negative 4w is negative 24w. Next, 2 goes into 6 3 times, and remember the sign. So 3 times negative 5 is negative 15. Next, 3 goes into 6 2 times, and 2 times positive 5w is positive 10w. And last, 3 goes into 6 2 times, and remember your sign. 2 times positive 2 is positive 4. So we need to isolate our variable. So I'm going to start by eliminating the 10 on the right hand side by taking its opposite. And negative 24 and negative 10 give me negative 34. Next, I'm going to add 15 to both sides. Now my variable is isolated completely on the left-hand side. And I'm going to divide by my coefficient, negative 34. So w would equal negative 19 over 34, or 19 over negative 34. It doesn't matter. Our next problem is just translating this sentence into an equation. 15 less than Chrissy's age is 60. So a key word is usually means you put your equal sign there. Now here's where you need to be careful. It says 15 less than Chrissy's age. So if Chrissy's age is C, 15 less than that would be minus 15. So it'd be C minus 15 is equals 60. Translate the sentence into an equation. Twice the difference of a number and 3 is 9. So there's your is again. So the difference of a number and 3. So it says use the variable w. So it says the difference. Difference means subtraction. So the difference of a number and 3 would be, in this case, w minus 3. Now twice the difference of a number and 3 means 2 times. So we have a 2 in front of our parentheses. And it says is equals 9. Now the next problem It says solve for x, and you notice we have more than one variable. It says x plus u equaling v. So we're going to go through the same process as we normally would do. We would remove parentheses, combine like terms, and isolate the variable that we're solving for. Since we're solving for x, we want x to be by itself. Now u is connected to x by addition, so if I want to eliminate the u, I'm going to take its opposite from both sides. Now on the left hand side, of course, that cancels out, gives us a 0, so that leaves us with just x. Now on the right hand side, these are not like terms, so we write them as two separate terms, v minus u. So we solve for x because we have one x isolated by itself. Our next problem, we're asked to solve for h, and we're given 2 equals b times h. So again, if I want to isolate something, I want it by itself. Now in this case, I need to eliminate the b. So you ask yourself, how is b connected to h? It's through multiplication. So if I need to remove that b from the h, I do the opposite operation. So I would divide both sides by b. It's like dividing by a coefficient, right? So on the right hand side, the b reduces and just leaves me with h. And on the left hand side, I have 2 over b. So I solved for h because I have one h isolated and there's no h's on the other side. So once you isolate and you make sure the coefficient is positive 1, then you have your answer. Solve for capital B. 9 times capital B plus capital C equals capital A. So again, the same process. We're solving for uppercase or capital B, so we need to isolate it. So C is connected to it by addition, so to get rid of the C, we subtract C from both sides. So on the left hand side, C minus C is 0, just leaving us with 9b. And on the right hand side, these are not like terms, so it's A minus C. Now think about what you would normally do in an equation. Once we come to this last step, we're solving for 1b. So right now it's 9, so we're going to divide both sides by 9. So on the left hand side, 9 over 9 is 1. That gives us 1b. And on the right hand side, we have A minus C all over 9. Let's look at another problem. Solve for y. We have 9 times the quantity y plus k equaling c. So just as we normally would do, we would use our distributive property, and 9 times y is 9y plus 9 times k is 9k, and that equals c. So we're solving for y, so we need to isolate. So that means I need to eliminate the 9k. Since it's added, I'm going to subtract it from both sides. So this leaves me with 9y equaling c minus 9k. Now I'm going to go through something a little bit more because there's two ways really to finish this problem. So one way is exactly what we did in the last problem. We're going to divide everything by 9, or both sides. So on the left hand side, That leaves us y. And on the right-hand side, we have c minus 9k over 9. Now, we cannot reduce because in order to reduce, we have to reduce something out of every term. So nothing goes into 9c and 9k. So that would be an acceptable answer, c minus 9k over 9. Now remember, I said there's another way. So another possibility is I'm going back to the step where we had 9y equaling c minus 9k. Now what you can also do is divide each term individually by the 9. So on the left-hand side, that reduces again to y. C over 9 cannot reduce. But here, 9 goes into 9 one time, so that would just leave us k. So another acceptable answer would be y equaling c over 9 minus k, written as two separate terms. Okay, so one more example. We have negative 1/3 equaling negative 5/3 v plus 2/9. So remember, when you have fractions in an equation, we want to clear the fractions by multiplying each term by the common denominator. So the common denominator of 3, 3, and 9 would be 9. But remember, as long as we use a number that 3, 3, and 9 all divide into, that's fine. So I'm going to rewrite this, negative 1/3 equaling negative 5/3 v plus 2 over 9. So I'm going to use the common multiple 9 and multiply each term by that common multiple. So as we did before, we reduce. So 3 goes into 9 3 times. And remember, don't forget your sign. 3 times negative 1 is negative 3. Next, 3 goes into 9 3 times. And again, don't forget your sign. 3 times negative 5v is negative 15v. And last, 9 goes into 9 one time, and 1 times positive 2 is positive 2. So now we're going to isolate. So since we only have one v and it's on the right hand side, I'm going to isolate it on the right hand side. So I need to eliminate the positive 2. So I'm going to subtract 2 from both sides. Negative 3 and negative 2 give me negative 5, equaling negative 15v. Now remember, we're solving for v, so we always divide by the coefficient of that variable. So we're dividing both sides by negative 15. Negative 15 over negative 15 gives me positive 1, so that's positive 1v. And remember, a negative over a negative is a positive, so that gives me 5 over 15. Now remember, we always look to see if we can reduce. So there is something that goes into both 5 and 15, and that would be 5. So I'm going to reduce by dividing 5 out of both the numerator and denominator. And that would give me 1 over 3. So my final answer would be v equaling 1/3.